Hi class, welcome to lesson 53. By the end of this lesson, you should be able to determine the products of a neutralization reaction and calculate the concentration of an unknown solution using a titration. Now, the process of neutralization occurs when an acid and a base are combined together to form both salt and water. One everyday application of neutralization is sometimes when people are experiencing acid reflux and excess of acid, they could take an antacid, which is really a base that will be able to neutralize the acid into a salt and water. In the process of neutralization, an acid and a base react to form salt and water. This is a very special kind of double replacement reaction. So you can see that the outside ions come together to make water, and the inside ions will come together to make a salt, any ionic compound that is combined so the total charge is 0. So by now you should be able to determine the products of a neutralization reaction. Now, neutralization can be applied by a laboratory technique called a titration. In a titration, what you do is you use a solution with a known concentration and you combine it with a solution of an unknown concentration until those solutions become neutralized. So typically, what you're going to do is you're going to fill a flask with in this case, we have an acid, but it could be an acid or a base. So you fill the flask with a known amount that you measure of a solution with an unknown concentration, and then you take a burette. This is like a long tube, like a graduated cylinder with a valve on the end of it, and you fill this with a base of a known concentration, and you're going to carefully mix the base into the acid, and you'll use the indicator to tell you when it's neutralized. Using this information, you will be able to calculate the exact concentration of the unknown solution. So that sounds like a lot. Let's see if we can break it down. So here you can see an example where I have an acid of an unknown concentration, and I'm going to add base of a known concentration to it until it perfectly neutralizes the acid. So I can calculate how concentrated that acid was. So when I add the base into the acid, it will join the acid and form water, which we know is a neutral compound. And we'll add the base, and we'll continually add the base until you can see over here, we've added just enough base to bond with all of the loose hydrogen ion concentration. So now we have a perfectly neutral solution. So here is a video showing somebody carrying out an acid-base titration. So there's a base coming through the burette and it's combining with the acid, and we're using the indicator phenolphthalein. Phenolphthalein is colorless in an acid, but it is purple in a base. So what we'll do is we'll continually add base until we can get the solution to indicate that it's no longer acidic, so it'll no longer be colorless, and instead it will remain pink. Since the solution will have changed color, we will know that it has been neutralized. We can use volume and molarity data to calculate the exact concentration of our unknown solution.
A titration is a controlled acid-base neutralization reaction. 20 milliliters of hydrochloric acid of an unknown molarity is added to a flask. 2 drops of indicator dye are added to the acidic solution. This indicator dye is clear in acidic solution and pink in basic solution. The burette is filled with a sodium hydroxide solution of known strength and an initial reading is taken. The base is added to the acidic solution until the solution stays a slightly pink color. At this endpoint, a final reading is taken. The moles of base added equal the moles of acid present.
So in order to complete a titration equation, we are going to use reference table T, where we can find this formula. Notice that the M is a capital M, and it stands for the molarity. So we're going to take the molarity of the acid times the volume of the acid and set that equal to the molarity of the base times the volume of the base. The unit for volume is not important as long as it is the same on both the acid and the base side. If they are not the same, you're going to have to convert to the same unit. For instance, you cannot have liters on one side and milliliters on another. Now let me show you how to complete a couple titration calculations. Make sure you follow along. These questions are listed in your guided notes. Or you can just copy the question from here. Feel free to pause the video whenever you need.
Let's see if we can do some practice calculations together. In this question, we are given 25 milliliters of a sample of nitric acid. And we see that it is neutralized. So neutralized is the key word that tells us that we are going to apply the titration formula from reference table T. Since I'm going to use the titration formula, I'm going to write down my formula, and I'm also going to write down a variable table so I can list the values of the variables that I know and that I'm looking for. Again, we have a 25 milliliter sample of nitric acid. So 25 milliliters is our volume of the acid. And it is neutralized by 32.1 milliliters of a 0.150 molar potassium hydroxide solution. So we can see that here we have the volume of the base, and here we have the molarity of the base. So we're looking for the concentration or molarity of the acid. From here, we're going to substitute into our equation from table T. Once we substitute, we can use our calculator to help us solve this problem. So you can see that our calculator answer comes out to 0.1926. Now when I look at the values given in the question, each value has 3 significant digits. So the best answer is 0.193 molar nitric acid. Let's look at another example. Here, we want to know how many milliliters of a 0.1 molar sodium hydroxide, which is a base, solution is required to neutralize. Again, we have that keyword that indicates we're going to use the titration formula, 20 milliliters of a 0.200 molar hydrochloric acid solution. So, since I have the word neutralize, I'm going to set up my equation from reference table T for titration. And then from there, I'm going to set up my variable table. And I'll read through the equation again to see if I can identify the variables. How many milliliters of a 0.100 molar sodium hydroxide? So this is the molarity of the base. And then I have 20 milliliters of an acid. So So that is the volume of the acid. For the volume unit here, you can use milliliters or liters as long as both volumes have the same unit. So I know that my base volume will be in milliliters because my acid volume is in milliliters. And I have the acid's molarity is 0.200. This means that I'm looking for the milliliters of base. Now I'm going to substitute into my formula. Again, we can use our calculator to solve. So here you can see that our calculator answer is 40. Now, when I look at each of these values, they're given to 3 significant digits. So the best answer is 40.0 milliliters. Let's do one more question together. Here, we are looking for how many milliliters of a 2.5 molar hydrochloric acid solution, so this is an acid, is required to exactly neutralize. So the word neutralize is our key word to use the titration formula from reference table T. 1,500 milliliters of a 5 molar sodium hydroxide, that's a base solution. So I'm going to set up my variable table. And rereading the question, I know that I have 2.5 molar acid. That's the molarity of the acid. I have 1,500 milliliters of base. And I have 5.0 molar solution of base. So I'm looking for the milliliters of acid. So when I substitute into my equation, it should look like this. And then we simply put this into our calculators. My calculator gives me a value of 3,000. Now, when I look back at the question, every number is written to 2 significant digits. So I should report my answer to 2 significant digits. So in scientific notation, it could be 3.0 times 10 to the third milliliters, or I can convert to liters. This accurately reflects the precision of the instruments used in lab. Here is one more question. Here we're looking for how many milliliters of a 0.200 molar sodium hydroxide, which is a base, are needed to neutralize. So that means we're going to titrate using the formula on reference table T. 100 milliliters of a 0.100 molar hydrochloric acid solution. So you should set up your variable table and see if you can identify the variables and solve. That's it for titration, folks. Make sure you've taken good notes and you bring all your questions to class. See you soon.
By now, you should be able to calculate the concentration of an unknown solution following a titration reaction. That's it. This is the end of Lesson 53 on titration calculations. Make sure you take good notes, write down any questions you have, and bring them to class. We'll answer them. Complete your homework on Google Classroom and put your materials away so that you'll be ready for the next class. I'll see you soon.